So welcome guys. Today we'll be doing another topic in our quantitative analysis, that's statistics, on measures of variation. That's measures of variation. This is what we are going to be studying today, and I'll try as much as possible to be simple and slow so that you can understand. For those of you who are having a hard time, especially in statistics or mathematics, don't be afraid. I said it in my other videos that I'm not a mathematics person or a statistics person, but with determination, and I just develop an interest. And again, if you are doing your ICAN classes or your ACCA classes or your tax management professional course or any administrative professional exam, this tutorial is what you actually need to get over an edge. Now today we'll be wondering, what is measure of variation all about? What does it mean? What's our business with it? You will learn everything here in just a moment. So my name still remains Fada Ray Ayola. So if you have any question, you can throw your question below. Kindly like and subscribe, and just in case you need more clarification, you can give me a call and I'll be glad to be at your service. Now, measure of variation or measures of variation, what does it mean? Well, for instance, it means when we say the degree, the degree to which numericals, that's your numbers 1 2 3 4 up to 0 to 9 and the combinations, if you understand what I mean. Numerical data tend to spread about or around an average. So what do we mean? Say the degree, that's the quantity or the extent or the frequency. So when you see degree, just have it at the back of your mind. We are talking of quantity, we are talking of frequency, we are talking of the length at which it goes, to which a numerical data. So numerical means numbers 0 to 9, 100, 20, 14, those kind of numbers, both integers and variable. So to which it tends to spread. Spread means scatter or go about your business. I'm trying as much as possible to give a mathematical definition, then also break it down to our literal meaning. So to spread about or around an average, so which means it spreads around an average. And what is average? Anything divided by 2. So the topics we are going to be treating today, we'll be treating range, we'll be treating mean deviation. We'll also be treating standard deviation. for today. In our next class, I will treat semi-interquartile or quartile deviation, coefficient of variation, and skewness. But today, let's just concentrate on these three fellows. Now, range. What do we understand by range? When they say predict the range, in literal form, range is just simply the highest against the lowest, or the difference between the highest and the lowest. So when we say range, what we are saying is that highest number minus lowest number. That's what it means when we say range. And this is for, note, this is for ungroup data. This is meant for ungroup data. What do we mean by ungroup data? Let's assume we have data like information. Data also means information. 32, 6, 27, 30, 5, 45. Now we are saying range is the highest subtracted by the lowest number. So what are we going to do? Let's look for the highest number. You can rearrange. It makes it easier. Especially this kind of question usually comes out once in a while in your theoretical aspect in ICAN or your ATS. It usually forms the number one question, number 1A, B, and C type of question. They will first give you such questions like a bonus for those of you who have been reading. So now say 5 is the least here, followed by 6. The next list here is 27, followed by 30. Then you look at it again, 32 follows, then 45. So 5 is the lowest, 45 is the highest. So we say 45 minus 5 gives us 40. This is our range. Pretty simple, eh? Okay. So now, note I said this is for ungroup data. Now let's go for the group data. So this is group. Now when we talk of group, let's assume we have a table, class, then frequency, then we have something like this, 1 to 10, frequency of 4, 11 to 20, frequency of 10, 21 to 30, frequency of 12, 31 to 40, frequency of 12 again, then 41 to 50, frequency of 9. Now, how do we get the range? The range here is simply the highest class minus the lower bound class. So you talk of the highest bound class minus lowest bound class. So here when you look at it, this is our lowest, this is the highest. We'll now subtract it. By subtracting, that's 50 minus 1 gives us 49. That is how you treat it for a group frequency class. That's the range. So if you get this in a theory, you know if this will normally form like question 1A, and question 1A that should give you your 3 marks, and with other ones 3 marks, you are sure that your question 1 you already have your 12 marks guaranteed in question 1. Now let's move a little bit further. We want to learn mean deviation. And this is mean deviation. Please don't mind my handwriting. People like us, we've tried as much as possible to have a good handwriting, but unfortunately we just tried. So mean deviation. What do we mean by mean deviation? I'll go to the definition later on, but let us take a look. Now, if we have ungroup data, for instance, let's look at this model x1, x2 up to xn. Then the mean deviation, permit me to use MD, is summation of modulus x minus mean over n, which gives us summation of d over n. Now you have to know this formula. Just have it at the back of your mind. I'm not saying you should cram it, just understand the formula. Now, what do we mean by this symbol? If you have watched my first video, you will understand it more. This means sigma, which does summation, which represents summation. That's addition, just adding up the whole entire frequency. Now, as you know, x is our data or numbers, or you can say information, but in statistics is our data or number. That's x within that frequency. Then the pipe symbol means modulus. The pipe symbol means modulus. Now, I was now curious, because I told you I'm not a major in statistics. So I was curious. I went on Google and I wanted to know what is actually the meaning of modulus. And this was what I got. Modulus means the non-negative. Take a note on this. Non-negative value of a number without regards to its sign. So that's either negative or positive without regards to its sign. So modulus means the non-negative value of a number without regards to its signs. So we are talking of positive or negative. It is also called, or it is actually called, the absolute value. So when they say modulus, just have it at the back of your mind that it's called an absolute value. Now all this grammar, what's actually this grammar trying to tell us? What it means is that as an absolute value, it cannot be negative. So no matter the information, the number that is being generated, once it comes out as a negative sign, if it's in a modulus, the absolute value will be positive automatically. So what do I mean? If, for instance, the value you get is -1 or -2 or -3 and so on, that minus automatically becomes positive. So instead of -1, it becomes 1, becomes 2, becomes 3, and so on. That is actually what modulus does in this aspect. So we also have another kind of formula, the same formula though. You remember this earlier that I've written. Now, if you are in a group data, for group data, this is what you will use. Let me manage the space I have here. Mean deviation will give us summation of f, that's the frequency, x, which is our data, minus mean over summation of f, which everything gives us summation of f modulus d all over summation of f. Don't worry, you're like having headache, right? Don't worry, you will understand. So note that summation f also implies n for our ungroup data, summation f in our group data. So mean deviation. Mean deviation, can you see now? On group. So you can pause the video, play it back again, and see all what we've done within this introduction. Now let's do some examples, or like what the accountant will say, some illustrations. Now let's get the mean deviation of this data. So say calculate the mean deviation is 15, 17, 14, 16, 18. This is an example of an ungroup data. So calculate the mean deviation. The first thing here you need to have at the back of your mind is that what is the formula for our mean deviation. Once you write that formula, it will be able to guide you. Now, what does the formula say? For our on-group formula, mean deviation, we have summation of modulus x minus mean x over n. So what we do is that we say, okay, mean deviation gives us the summation modulus x minus our mean, arithmetic mean, over n, which also gives us summation of d over n, because note x minus mean is equals to d. So that is what it means. X minus mean equals to d. So let's go further. Now, the first thing we need to do is to first of all find the mean. So x mean. What is the mean? Mean simply is summation of x over total number of frequency, or number of frequency. Now, our x is 15 plus 17 plus 14 plus 16 plus 18. Total number of items 1, 2, 3, 4, 5. 5. So once we add all this up, 15 plus 17 plus 14 plus 16 plus 18 gives us 80. 80 over 5 will give us 16. So this is our mean. We've gotten our mean. Now we can dive straight to the formula. Now, the formula itself, once you look at it, what does the formula say? It says summation of the modulus x minus mean over n. So we'll create a small table. Let's create a small table. X is 15, 17, 14, 16, 18. Now our d, which we all know as x minus mean x, mean. So what we mean is 15 minus 16 equals minus 1. 17 minus 16 equals 1. 14 minus 16 equals minus 2. 16 minus 16, that's 0. 18 minus 16 equals 2. So our d, or modulus d, and you know the definition of modulus, this will now be 1, 1, minus 2 will be 2, 0, 2. So the summation of d, modulus d, will give us 6. Are you following me? Just take your time. Don't rush. Look at it very well. Don't be too scared. Now, the next thing we are now going to do is the mean deviation, MD, equals summation D over N. And what is our N? N is 5. What is our D? D is 6 over 5. It gives us 1.20. Gives us 1.20. 0. So the next thing we are now going to do is to get the mean deviation for a group data. Mean deviation for a group data. So mean deviation for a group data. What are we actually saying? We saw earlier on how we treated the mean deviation for an ungroup data. Now I have this table. Class, frequency is 1 to 10, frequency is 10, level to 20, frequency is 15, 21 to 30, frequency is 17, 31 to 40, frequency is 13, 41 to 50, frequency is 0.5. Now this is our table. So we want to find the mean deviation of this group data now. How are we going to go about it? Now, I will need to, just for this tutorial sake, I will extend this table, but not to say the least, just go along with me. Now we need to find x. Then f of x, then our d, that's the difference, which you all know as x minus mean, then f of d. Now our frequency and our x. Now what is our x here? You now wonder, how do we get x? If you have watched my introductory class, you know that our x is the midpoint of the class. Just take some time and go back and watch my very first episode, then you will understand better. So what we are saying here is that in this class, our midpoint is 1 plus 10 over 2, which will give us, so we'll say 1 plus 10 divided by 2 gives us 5.5. So this gives us 5.5. 11 plus 20 divided by 2 gives us 15. Gives us 15.5. This gives us, that's 21 plus 30 gives us 25.5. This is 35.5, and this is 45.5. Hope you get the way I got my midpoint. Now the total of f here, that's total frequency. If you add 10 plus 15, which is 25, plus 17 plus 13 plus 5, total will give us 60. Now f of x, that's f multiplied by x, that's 10 multiplied by 5.5 gives us 55. 15 multiplied by 15.5 gives us 232.5. 70 17 multiplied by 25.5 gives us 433.5, and 35 multiplied by 13 multiplied by 35.5 gives us 461.5, and 5 multiplied by 45.5 gives us 227.5. So when you add 55, 232.5, 433.5, 461.5, and 227.5, we have a value of 1410. Now, our x multiplied by our mean. How do we get our mean? If you can remember the way we get our mean equals summation f of x over summation f. So what is our f of x, summation of f of x? Our summation of f of x is 1410, and our f, summation of f, is 60. So 1410 divided by 60. Let's do the division together. 1410 divided by 60 . 1410 divided by 60 gives us 23.5. So this gives us 23.5. So this is our mean. So from there, we'll now come here. We'll say x 5.5 minus 23.5. So our x is 5.5 minus 23.5 gives us minus 18. But you have to remember that the d, our difference here, is an absolute value. So 18, since it's an absolute value, this is minus 18, but automatically gives us 18 as an absolute value. Then the rest, this is 8, this is 2, this is 12, this is 22. That's my battery, phone battery. This is 22. So f of d, that's frequency 10 multiplied by 18, gives you 180. 15 multiplied by 8 gives us 120. 17 multiplied by 2 gives us 34. 13 multiplied by 12 gives us 156. Then 5 multiplied by 22, 110. So the total is 600. So our mean deviation now, MD, is now summation f modulus d summation over summation f, which gives, so our mean deviation is now summation f of d over summation f, that's 600 over 60, which automatically gives us 10. That is our mean deviation for a group data. So you just calm down. Go through the tutorial, and I'll be back with standard deviation. Thank you.